非常感谢有这个机会来在这里做一个报告。今天晚上呢，我们已经探讨了很多的关于一些增强的关键技术，还有一些5G 的一些新的技术。那在接下来的15分钟呢，我想来聚焦一下我们如何去进行面向行业的5G 上行，提高我们的增强关键技术以及解决方案。那在我们的行业里面呢，其实有很多的应用，包括我们的这个单用户还有单小区的这个应用是非常重要的。我们能够看到有一些非常高质量、高清的视频呀，还有照片呀，都是非常高清的。那这些应用，尤其是一些这个工厂啊、制造的场景呢，有很多的传感器啊，这样的场景，或者说有很多的这种监控的这个摄像头，他们其实占据了很多的这个上行的能力。所以我们作为这个第三方呢，其实发现说我们可以去做更多的一些努力，而且在目前行业，这个面临着越来越大的、越来越高的一个要求，对于5G 上行的这个增强。那尤其是在我们的这个基础设施方面，我们看到其实我们有很多的这个非常强大的一些技术解决方案。那么这是我们想要去解决问题的一个底层的逻辑。那么我们中心目前所提供的一个技术呢，其实我们通过多种的创新来去提升网络以及终端的效率以及性能，包括一些非常强大的一些支持，其实而且用起来是非常简便、好操作的。我们将这些频谱结合在一起，从单频谱到多频谱，帮它们结合起来，来去实现更大的一个上行的能力。我们也聚集了很多的技术，包括我们有一个聚合的一个 TDD，灵活动态的 TDD。
Good. The screen is good, right? Hello?
Yes, countries, it seems good.
Okay. So I first want to just address,
The
the next one, right? Yeah. So so we have several different approaches that we first that from system side and also from terminal side. And from system side, it's very intuitively to think that we need to add more spectrum, more band to the system, and we also need to using those bands or spectrum more dynamically. So we have that fusion or assisted super TDD, FDD plus TDD solutions, and which can improve the uplink a lot. And also the network architecture, we have that distributed MIMO built into the indoor solutions, and some other dynamic or flexible TDD, which give more flexibility to the frame structure, making that more flexible to have a more chance to send data upwards. And besides that, ZT also have AI-based technologies like radio composer. It's a kind of orchestration technologies. We have that database of different layers performance and put that into use and can guide different users and applications to different layers to improve the user experience. Both uplink and downlink can be improved. And also in our industry, we have some new technologies, just like 3GPP, we have some new technology in the aggregated UEs, and later on we'll explain all of those features in more details. Okay, so this slide is a kind of a refresh of different frame structure combinations. So generally speaking, you can find that if without that 1D3U, that uplink enhanced frame structure, most of those other frame structure got very poor or low that uplink performance. But even with that 1D3U, that uplink still is less than 1G, still some headroom for improvement. So here come to just one of the features we have that to improve the uplink capabilities. The first one that is bundling that two bands together and the two different frame structures. You can see that one is a 72U and another one is 2.5 millisecond dual frame structures. With that, we have a little offset in the header and gives uplink a better chance to have to transmit data. And with this tweak, we can improve the uplink capability to around to a little bit over 500 megabps theoretically. And this is not enough, and we introduce that to complementary CAs, which is in here you can find that on the right part in the N79 we have that uplink switching, TX switching. So with that D slots, and we switch all of that to U slots. So all of that, the whole frame structure, and we have we turned all of that to nearly all of that possible frame to slot to uplink. So this can give a little bit over 1 Gbps of throughput. So this is the frame structure, the kind of maneuver to enhance the uplink capabilities. This is a very good technology and a good feature, but it also introduced some kinds of challenges. Like in here, you can see we have example 73U and also that 1D3U. If with that kind of different frame structure, you will experience some interference because at that the lower left, we elaborated that in the downlink part, the interference base station, the downlink will cause a severe interference for the uplink. So, and also the closer it gets to that location, and it's the strength of the interference will be higher. So this is will cause some this kind of traffic loss, about 30 to 40% of that traffic loss. And nowadays we have first of all we have a slot level AMC, adaptive modulation coding solutions, and just to guarantee that some of those slots won't be affected at all. And secondly, we have that service-based scheduling priority guarantees this kind of feature, which means that we can put higher priority application to that to the green U slots, not the lighter blue, that kind of slots. The fifth one, yeah. So with that slots, we have just a better interference, and this can improve the total performance. One is we try to coordinate with the interference station. That is, we have a way to send the information to the interference station and tell them to just change the beam or beam direction and to tune down the interference. This is one other way, or this is one way. Another way of that is to using that DMIMO, that UE in a group. For example, in a area that the UE is in the interference location, but the neighbor UE is not in the interference areas, so that they can communicate with another UE and making that UE to work as a relay to communicate with the base station and transmit data between the two UEs to eliminate the interference in those two ways. The first one I had mentioned that is to tune down the interference source. Another way is to just work different UE that the group, find a UE which is not interference and talk to that UE as a relay. With all of those combined, we can reduce the interference as much as 20 dB, somewhere around 10 to 20 dB. So this is something we've been working on, and 3GPP has been working on. That will be introduced in the future. So this is that feature, dynamic or flexible TDD. And the next one is about those indoor performance enhancement. The left part is about that the logic cell is a big logic cell, but if we need a bigger capacity, we can speed it up. We can split the logic cell into multiple logic cells, improve the capacity. This is one approach. On the right is another approach, which is the Q cells or PRUs form a big massive MIMO group. And we can form as much as 32 TR in a group, and it can work as the massive MIMO to those being formed into different MU MIMO to different UEs. With that capabilities, we can improve the total cell capability to 3 times more. This is the two approach. Just one is a split, another one is combining together to form a massive MIMO. So this is the indoor enhancement. And the next one is the one I mentioned about using that orchestration. In here you see that we form a database of the different layer, different technologies. For example, like 5G NR, different bands. We have that radio fingerprint, and we store that into our system. And with that, we can reduce some of those MR measurement requirements. So with that, we can reduce a lot of handover delays, because that measurement process can be just deleted. Without those measurement processes, still can establish those handovers. And also that especially the end, or the kind of the poor sites, this kind of the far sites, we have a very poor that spectrum efficiency at that layer, and we can guide that UE to a more spectrum efficient layers, which can improve the users that the edge performance greatly. So with all of those combined, we can greatly improve that edge average throughput, and also reduce a lot of handover delays. So this is by those kind of AI-based technologies or algorithm to give the base station more capabilities. Okay, then the last one is the one I mentioned about the UE aggregation. Because comparing to the network infrastructure, the UE is just powerless. Just no matter for the output power or the PRB capabilities, or those bandwidth for the red cap terminals, it got a lot of limitations. So this is a pretty new, recently, just in August, has been formed the side link as a side link relay as the working item in the 3GPP. And the total that those kind of the feature will be finalized in the end of the next year, 2023, just by standard. So it's a pretty new technologies, and we can have enhancement in 2 ways. First of all, that is like in the edge, you have a very poor radio performance, and we can just establish a relay with some UEs in a better position, and we can just improve the edge performance. This is very one way. And another way, that is if you are in the center, but your UE is limited to 2 layers, but we can bundle 2 UEs or multiple UEs together, and we can have more layers of data transmission capabilities. So this is basically the 2 capabilities. And also with that bundling, we also enhance or double the output power of the UE. So with all of that, and we can, in the IoT vertical application, we can making the IoT vertical users into a vertical group and enhance the group's capabilities. So the total performance of that, no matter for uplink and downlink, can be improved greatly. And up to now, as a vendor, we've already started the testing of that UE in the edge with some TUE stuff, and also that improving the more streams, just breaking the two stream limitation, improve that to 4 stream. We have just to put into test, and we will see that more progress in the 3GPP and also in our lab about this feature. So with all of those combination of multiple technologies, and we believe that we can together enhance uplink capabilities, especially for the IoT applications, and have a better chance for our mobile industry to address the vertical application and opportunities and challenges. Okay, so this is my sharing part, and back to you, Mr. Shao.